Imagine living in a world where every time you switch on a light, charge your phone, or ride an electric train, you're relying on the work of someone whose name many people barely recognize. Yet one of the greatest minds in scientific history started life with almost nothing. Long before he transformed our understanding of electricity, Michael Faraday was simply a poor boy growing up on the streets of London. His journey from poverty to worldwide influence remains one of the most remarkable true stories in the history of science. Michael Faraday was born on September 22, 1791, in Newington Butts, South London, to a family struggling to survive. His father, James Faraday, worked as a blacksmith, but poor health often prevented him from earning a steady income. Money was always scarce, and the family lived a modest life, moving wherever they could afford to stay. Food itself was sometimes limited. Historical accounts suggest that young Michael had to stretch a single loaf of bread across an entire week. Opportunities were just as scarce as food. His education was brief, consisting of only the basics of reading, writing, and arithmetic before financial hardship forced him to leave school at an early age. By the age of 13, childhood had given way to responsibility. Michael found work as an errand boy in a London bookshop owned by George Ribot. At first, his duties were simple, delivering newspapers, sweeping floors, and carrying parcels through the busy streets. Nothing about the job hinted that it would change the course of scientific history. But hidden among the shelves of that quiet shop was something far more valuable than money: unlimited access to books. Without realizing it, the young apprentice had stepped into the place where his extraordinary future would quietly begin. In the next chapter, an unexpected habit inside that bookshop would open a door that no university ever could. The small London bookshop where Michael Faraday worked looked ordinary from the outside. Customers came and went, books were repaired, and newspapers were delivered as part of the daily routine. But for a young apprentice with an endless curiosity, it became something far more important than a workplace. It became his classroom. Around the age of 14, Faraday began a 7-year apprenticeship as a bookbinder under George Ribot. His job required patience and precision. Every day he stitched loose pages together, pressed books into leather covers, and carefully restored worn volumes. As his hands mastered the craft of bookbinding, his mind was discovering an entirely different world. Unlike most apprentices, Faraday didn't simply handle the books, he read them whenever he had the chance. Science texts quickly became his favorite. He studied articles on chemistry, electricity, and the natural world, often continuing late into the evening after his work was finished. One book made a particularly lasting impression: Conversations on Chemistry by Jane Marcet. Written in clear, accessible language, it introduced complex scientific ideas in a way that someone without a formal education could understand. Reading alone wasn't enough for Faraday. He wanted to test what he was learning. Using the small amount of money he earned, he bought inexpensive materials such as wires, bottles, and pieces of metal. In his spare time, he recreated simple experiments, carefully comparing the results with what he had read. His tiny workspace slowly became a personal laboratory where every successful experiment strengthened his confidence. Then, in 1812, an opportunity arrived that seemed almost impossible. A customer of the bookshop offered Faraday a ticket to attend a series of public lectures at London's Royal Institution. The speaker was Sir Humphry Davy, one of Britain's most celebrated scientists. Faraday had no way of knowing it, but those lectures were about to change the direction of his life forever. In the next chapter, a notebook filled with careful observations would reach one of Britain's greatest scientists, and open a door that many believed would always remain closed. In 1812, Michael Faraday walked into the Royal Institution as an unknown apprentice. He wasn't a university student, a scientist, or even a member of Britain's educated elite. He was simply a young bookbinder eager to learn from the country's most respected chemist, Sir Humphry Davy. From the moment the lectures began, Faraday paid close attention to every demonstration. Rather than listening casually, he carefully recorded the experiments, explanations, and diagrams in remarkable detail. His notes eventually filled hundreds of pages, reflecting not only what he had heard but also his determination to understand every scientific principle being presented. When the lecture series ended, Faraday did something that reflected both his profession and his ambition. He neatly organized his handwritten notes, bound them into a finely crafted volume, and sent the finished notebook to Humphry Davy along with a respectful letter. In it, he explained that he hoped to leave the trade of bookbinding and dedicate his life to science. He made it clear that he was willing to begin with even the most basic laboratory work if it meant having the opportunity to learn. The notebook immediately stood out. Davy was impressed by the quality of Faraday's observations, the careful illustrations, and the discipline shown by someone with almost no formal education. Historical accounts record that Davy sought advice from a colleague about the young man, receiving the suggestion that if Faraday truly wanted to become a scientist, he would willingly accept even the humblest position in a laboratory. That opportunity arrived in March 1813. At just 21 years old, Michael Faraday was appointed as a laboratory assistant at the Royal Institution. His responsibilities included cleaning scientific equipment, preparing chemicals, maintaining laboratory apparatus, and assisting senior researchers during experiments. The work was modest, and the salary was lower than what he had earned as a bookbinder, but none of that discouraged him. Faraday had finally crossed the threshold into the world he had dreamed of for years. Yet earning a place inside the laboratory was only the beginning. Soon, an unexpected journey across Europe would test his character as much as it expanded his scientific knowledge. Michael Faraday's new position at the Royal Institution was only the beginning of a much larger journey. Shortly after joining the laboratory, he accompanied Sir Humphry Davy on an extended scientific tour across Europe. The trip gave Faraday an extraordinary opportunity to visit leading laboratories in France, Italy, Switzerland, and other parts of the continent, where he observed many of the greatest scientific minds of the era at work. The journey, however, was not always easy. Historical records show that Lady Davy, Humphry Davy's wife, regarded Faraday as a servant rather than a fellow member of the scientific party. Although the treatment was discouraging, Faraday remained focused on the purpose of the trip. He filled notebook after notebook with observations, carefully studying new experiments, laboratory techniques, and the methods of Europe's leading researchers. Instead of allowing difficult circumstances to distract him, he used the experience to strengthen his knowledge. When Faraday returned to London in 1815, he devoted himself completely to experimental science. His careful approach soon earned the respect of his colleagues. Every experiment was recorded in detail, every observation checked repeatedly, and every conclusion supported by evidence. Over time, he began conducting research of his own instead of simply assisting others. Then, in 1821, Faraday achieved a breakthrough that would become one of the milestones in technological history. Inspired by recent discoveries linking electricity and magnetism, he designed an experiment using a wire, a magnet, and a chemical battery. As electric current flowed through the apparatus, the wire continuously rotated around the magnet. For the first time, electrical energy had been converted into continuous mechanical motion. Although the device was simple, its importance was enormous. Historians recognize this experiment as the first demonstration of the principle behind the electric motor. Modern appliances, industrial machinery, electric trains, and countless other technologies all trace their origins to this remarkable achievement. But success came with an unexpected cost. As Faraday's reputation grew, not everyone celebrated his accomplishments. Questions about credit, recognition, and loyalty would soon place his relationship with his mentor under intense strain. By the early 1830s, Michael Faraday had already earned the respect of many scientists through years of careful experimentation. Yet he believed that one of the greatest mysteries in physics remained unsolved. Researchers had already shown that an electric current could produce a magnetic field. Faraday wanted to answer the opposite question: could a magnetic field be used to generate electricity? For years, he designed experiments, tested new ideas, and carefully recorded every result. Many attempts failed to produce the answer he was searching for. But Faraday understood that scientific progress often depended on patience rather than speed. In August 1831, that patience paid off. Working inside his laboratory at the Royal Institution, Faraday wrapped 2 coils of copper wire around a single iron ring. One coil was connected to a battery, while the other was attached to a sensitive measuring instrument capable of detecting even the smallest electrical current. As he connected and disconnected the battery, he noticed something extraordinary. The instrument's needle moved briefly each time the magnetic field changed. That tiny movement revealed an entirely new principle of nature. Faraday had demonstrated electromagnetic induction, the discovery that a changing magnetic field can generate an electric current. Although the experiment appeared simple, its consequences would reshape civilization. Modern electrical generators, transformers, and power stations all rely on this same principle to produce and distribute electricity. Every city powered by an electrical grid, every home illuminated at night, and countless technologies used around the world can trace their origins to that breakthrough in 1831. Remarkably, Faraday reached this discovery without advanced mathematical training. Instead, he relied on observation, carefully designed experiments, and an exceptional ability to recognize patterns in nature. His work would later provide the foundation that physicist James Clerk Maxwell expressed through mathematical equations, helping establish the science of electromagnetism. Faraday's reputation now extended far beyond Britain. Honors and recognition followed from every direction, but the choices he made after achieving worldwide fame would reveal even more about the man behind the discoveries. As Michael Faraday's discoveries transformed the scientific world, his reputation continued to grow. By the middle of the 19th century, he was recognized as one of Britain's leading experimental scientists. Yet unlike many famous figures of his era, Faraday showed little interest in wealth, titles, or public recognition. His greatest satisfaction came from understanding nature and sharing that knowledge with others. Faraday's groundbreaking research inspired scientists across Europe. His concept of invisible lines of force helped reshape the study of electricity and magnetism. Years later, Scottish physicist James Clerk Maxwell translated many of Faraday's experimental ideas into mathematical equations, creating the foundation of classical electromagnetism. Decades after that, Albert Einstein acknowledged the importance of Faraday's contributions, and Faraday's portrait was among those displayed in Einstein's study alongside other scientific pioneers. Despite receiving extraordinary recognition, Faraday repeatedly declined some of Britain's highest honors. Historical records show that he refused a knighthood and twice turned down the presidency of the Royal Society. He preferred to continue his research without the responsibilities and public attention that accompanied such positions. His focus remained firmly on science rather than status. Faraday also believed that scientific knowledge should be available to everyone, not just scholars or members of the upper class. At the Royal Institution, he became famous for the Christmas Lectures, a series of demonstrations designed especially for young audiences. Using simple experiments involving candles, magnets, glass, and everyday materials, he explained complex scientific ideas in clear language that families and children could understand. Those lectures became one of Britain's longest-running scientific traditions and continue today. During his later years, Faraday's health gradually declined. Historians believe that years of exposure to chemicals used in 19th-century laboratories may have contributed to memory problems, although the exact cause has never been established with certainty. As his memory weakened, he slowly reduced his scientific work, bringing to a close one of the most remarkable research careers in history. But even as his health faded, the discoveries he left behind continued to power a world that was only beginning to understand their true significance. His final chapter would become as humble as the life he had always chosen to live. In the final years of his life, Michael Faraday stepped away from the laboratory that had defined his remarkable career. His memory had begun to decline, making it increasingly difficult to continue the demanding experimental work he loved. Although historians have suggested that long-term exposure to chemicals commonly used in 19th-century laboratories may have played a role, no definitive cause has ever been established. What is certain is that Faraday gradually withdrew from active scientific research while remaining deeply respected by the scientific community. On August 25, 1867, Michael Faraday died at the age of 75. In keeping with the modest life he had always lived, he was buried in Highgate Cemetery in London beneath a simple gravestone. He had declined many of the honors offered to him during his lifetime, choosing humility over prestige. For Faraday, the pursuit of knowledge had always been more important than fame. Yet his influence only grew after his death. Today, nearly every modern electrical system depends on principles that Faraday first demonstrated through careful experimentation. Electric generators, transformers, motors, and power grids all rely on electromagnetic induction, the breakthrough that changed the course of human history. Without his discoveries, the technological world we know today would look completely different. His ideas also shaped future generations of scientists. James Clerk Maxwell transformed Faraday's experimental insights into mathematical theory, while Albert Einstein openly admired his contributions to physics. Faraday's work became one of the foundations upon which modern science was built. Unlike many historical stories, Michael Faraday's life is not surrounded by unsolved mysteries or disputed legends. The facts are remarkably well documented through his notebooks, published papers, letters, and records preserved by the Royal Institution. His greatest achievement was not a single invention but a lifelong commitment to observation, curiosity, and disciplined experimentation. Perhaps that is why his story continues to inspire people around the world. It proves that extraordinary discoveries do not always begin in famous universities or wealthy families. Sometimes, they begin in a small bookshop, with a curious young apprentice who refused to stop learning. If you enjoyed this journey through the life of Michael Faraday, don't forget to subscribe for more documentary stories about the remarkable people whose ideas changed history. And tell us in the comments, which moment of Faraday's journey impressed you the most? Thank you for watching, and we'll see you in the next documentary.